welcome back to my channel Kuluru Vineeth. So I'll be continuing the arrays playlist. So today's question is removing duplicates from sorted input array. Okay, so here what the question looks like. So let's take an example here. Given input array of consisting elements of 1 comma 1 comma 2 comma 2 comma 2 comma 3, and our output should look like 1 comma. Right, now the question is clear, right? Given an array consisting of duplicate elements, our output should be an array consisting of distinct elements, right? So okay, fine. Now coming down to the intuition or approach for this question is straightforward. What I'll do is I'll take one extra array and keep comparing the adjacent elements in given input array, and if I see those are unique, then I'll push that elements into the new array which I have created. Okay, so let me write down that approach so that it will be clear for all of us. Okay, let me name this as approach 1, that is using new extra array, and name this as approach 1, and input would be integers array and return type also would be integers array. Okay, so let me name new array as new array itself. So this would be of int array, and make this as the size of the input array, and also take new pointer so that I can use to store elements in the new array. Okay, now I will iterate through given input array. Okay, so here what I'll do is simple. I will check if nums of I is not equals to the nums of I minus 1, that is I'll check the adjacent elements. If this is the case, what I'll do is I will straight away push nums of I into new array. Okay, and at last I will push 0th elements also into new array. Okay, and finally I will return until z. Okay, so this is simple, comparing adjacent elements and storing the all distinct elements in new array, and finally return that array consisting of unique elements which are stored in the new array. So this would give us our required answer. Fine. So now coming down to the time and space complexity, as we see we are traversing the array at least once, so that is the order of n, and coming down to space complexity, as I'm using an extra array of size n, it would be order of n. So let me write down that here as well. Time would be order of n, and space would be order of n, right? So this was our approach 1 for this question. Well, is there any other approach that we could come up with this question? Okay, fine. To optimize the space we have used in the previous approach, what I could say is yes, with just one pointer we could achieve the solution for this question. So let me write down that approach as well. Okay, so approach 2 using extra pointer. Okay, so let me name this as approach 2, and input remains the same, but here the output I'll just return the size of the new distinct elements containing array. Okay, so let me name this. I'll take here one extra pointer. Okay, now I will iterate through given input array. So what I will do here is I will check if nums of I is not equal to nums of z. Okay, what I will do is I will increment z and store nums of I into this. Fine. So finally what I will do is I will return the z plus 1, which would be the size of the array consisting distinct elements. Okay, so this was the approach to which would achieve the solution for the given question. Now coming down to time and space complexity, since we're traversing the array 1, so it will be order of n, and we are using just one extra variable, that is j, so it will be order of 1 space complexity. So let me write down that here. Time is order of n and space is order of 1, right? So this was approach 2 for this question. Well, is there any other approach for this question? Well, I would say there is already an inbuilt higher order function available in Kotlin library, which is a distinct, that would return the distinct elements in the given input array. So let me write down that approach as well. Using inbuilt higher order distinct function. Okay, so let me name this as approach 3, and input remains same and output will be integers array, and it is just one line thing, so I will straight away use distinct and convert this into the integers array, right? So this would give us our array consisting of distinct elements. Now coming down to the time and space complexity, since behind the scenes it uses the optimized approach which we have written in the approach 2, so time and space complexity would be same as approach 2, that is order of n and order of 1 respectively. Okay, yeah, these are the three approaches for this question. Now let's execute the each approach and compare the output of them. Okay, so I will initialize the object of the above class I have created, that is remove duplicates from sorted array, and I will store result of approach 1 in variable called approach 1. So let me call that function. So let me take same example as I have shown above. Okay, and print that as approach 1 and iterate through array of approach 1 and print. Okay, and for approach 2 I will straight away print size of the distinct elements array. Okay, so let me call that respective function. So let me take this, okay, and for approach 3 let me do same here, just a second. Okay, approach 3 here, approach 3, approach 3 here, approach 3, and here let me print one line, and now let's execute and see what the output looks like. Well, there we go. As we see, the output for approach 1, approach 2 and approach 3 are same, except the approach 2 we are printing the size of the distinct elements array size. In approach 1 we see the distinct elements are 2 3 1, and approach 3 distinct elements are 1 2 3. Well, yeah, that's it for this video. Thank you so much for your love and support. Keep watching and keep supporting my channel. There'll be a lot more exciting content coming up your way. Thank you.